CloudDB, shaping your new normal.
Hi everyone, full disclosure, this is actually a pre-recorded session. The reason is we are having some dramas with the latency between Perth and the event, and therefore the problem was I didn't want you sitting there waiting 10 seconds every time I press next slide for me to catch up and have the audio out of sync, etc. But I'm here in the Q&A in the chat, so I'm here live, but just if you have questions, throw them in the chat and I'll answer them. But hopefully you enjoy this and hopefully there's no latency issues. On with the show. So PL SQL, still super cool even after all these years. Why would we want to talk about that? Before we do so, a little bit about me. My name's Connor McDonald. I love talking about technology. You can reach me on Twitter if you want to have just casual conversations. If you like your forms of information a bit more longer in terms of their content, you can hit my blog. And if you prefer video, then obviously just reach out to me on my YouTube channel. Almost about to tick over 500 videos now, so hopefully something there for everybody. This is what I do most of the day. I look after the asktom.oracle.com website. It's a facility where we do Q&A to help you be more successful with the Oracle database. Before we begin, as I've been doing for many of my talks over the past couple of years, please, as useful and as productive as these virtual events are, let's make sure that we can get back to face-to-face events. I think the true value is coming together in person where we can talk about our successes, our challenges, our failures. So please get yourself vaccinated, follow your local guidelines and laws because we want our communities to be back face-to-face as soon as possible. A few ground rules which I think are important for this session. This session is not about some sort of religious or philosophical debate about PL SQL versus other languages. Whenever we talk about where code should reside, in the database, in the middle tier, on the client, people get very emotionally invested. They get very, very defensive about their particular personal preferences. This is not about that. I want this talk to be solely about one thing, building successful applications with the Oracle database. Now, my definition of success are pretty simple. It needs to, first of all, any application meet the business objectives. It's no use building an application that doesn't work for actual customer requirements. So priority one obviously is satisfying the business objectives. The second thing is satisfying the performance objectives. I don't care if your application does exactly what the customers need. If they need the results in 10 minutes and you can only deliver them in 10 weeks, then it doesn't really matter. Performance is actually really a business objective as well. Customers need applications to do what they need them to do in a reasonable time frame. It also needs to meet the development objectives. The best application in the world is no good if it takes 10 years to build, because by that stage, the application requirements have naturally moved on. And it also needs to meet the security objectives. Why? Because in the modern world, people generally will even forgive a site outage or application outage nowadays. What they won't forgive is if you get hacked. Customer trust is everything nowadays, and the easiest way to lose that trust is to give their data away because you didn't build a secure application. And let's be real about all those things. All those things really come down to one thing only when it comes to building application, and that is money. Ultimately, companies build IT applications to have some sort of commercial success. And the drivers for these two things when we're building IT applications is pretty simple. Spend less money if possible, and use those applications to make more money. So spend less building and making those and running those applications and make more money as a result of having those applications there. And this session is about, can PL SQL help you achieve those business objectives of having successful applications in order to meet commercial expectations of your business? If we look at the origins of PL SQL, fundamentally it comes back to where it probably really came into its own was back in the client-server days. Remember in the mid-90s, people were saying client-server was the future of computing. We were coming out of the mainframe era, and the fact that we could have something powerful on our desktop absolutely blew people's minds, and so we built client-server applications. All the logic running on the client, getting data from a remote database. Obviously, the issue there was that of latency. And perhaps the best way to describe latency was to talk about client-server in real life. Having seen that, you're probably thinking, we would never do that. We're not stupid. Yes, that's a humorous little video, but no way we would actually translate that into the building of applications. But the reality is everybody did. And perhaps the reason this has been forgotten is nowadays in the N-tier architecture or the internet age, people say, oh, it's no longer an issue in terms of latency, etc., because we have application servers. We don't have the logic on the client anymore. They're generally just browsers. The logic is on the app server. The app server is stored in the data center next to the database. The network lines between these two are incredibly fast. It's no longer an issue. Thus, the question becomes, is PL/SQL still relevant? Now that we've solved the client-server issue of not having client-server programs anymore, do we actually need PL/SQL to solve these problems? But let's remember the definition of success. Performance, maintenance, development, security. Can PL/SQL help with those? A small digression first. I want to talk about utopia. And when I talk about utopia is perhaps one of the failings of PL/SQL over the past maybe decade is whenever you've encountered white papers, talks on PL/SQL, you may have seen something like this incredibly complicated reference architecture on how to best architect an application to take advantage of PL/SQL. You can see there's a lot of layers in there, recommendations in terms of where you should store your data access code, your application access code, having a JSON shim around things, very carefully granular defined application attributes in PL/SQL to control all the security needs, etc. It was known as SmartDB. And don't get me wrong, SmartDB is an excellent reference architecture. If you want to see more details about it, you can go to dzone.com where we've collected all the articles we can find about smart database technology. But here's the key thing. The term utopia, we can see that the definition it says, this perfect world. But that's not exactly the definition of utopia. If we look up a bit carefully, I took out one word, which is it's an imaginary place where everything is perfect. And perhaps this is where people have got caught up too much in the philosophical and religious debates about PL/SQL. In my experience, the percentage of people out there using SmartDB as per the reference architecture is very, very small because it's a significant undertaking for any application development. Now, that's okay. The thing that I am not particularly pleased with is when people haven't been using SmartDB. There have been people in the community and people inside Oracle as well that have said, well, that means you're failing. If you haven't used SmartDB, then you're failing. You're obviously going to have problems, which is not necessarily the case. Similarly, those people that have embraced the principles and reference architecture of SmartDB, sometimes for their particular needs, they just get to almost a full SmartDB implementation. They eliminate some parts because it's either too complicated or it's not required for their particular application. They've just sort of fallen a little bit short. Now, for me, once again, that's not an issue, but due to those emotions in the community, people say, oh, you're failing. As a result, there's been that inclination to say, well, if I'm not going to go 100% SmartDB as per the reference architecture, then why bother at all? And therefore, people tend to get sort of almost scared from using a PL/SQL-based model because they're not coming up to the utopian dream of the SmartDB architecture. But as I said, let's forget about philosophy. Let's forget about philosophical debates. Let's just focus on success. Can a little bit of PL/SQL help? To explore that, we're going to focus on those business objectives. Let's start with performance first. As I said, people now say, oh, I've got app servers, it's okay. I no longer need to put database resident code in my applications because the concept of running it on an app server, it's close enough to a database server anyway. It's all in the data center. Why do we need to bother? But here is my postulate on this. No matter what platform you're using, and nowadays what are the popular ones? We've got things like Python and Node and Java, C#, you name it. They all get data from the database. And no matter what direction that data is going, sometimes it's going in, sometimes it's going out, depending on your application requirements. Typically it's both, but often one particular application has a dominance in terms of it's query heavy or it's ingest heavy. The reality is it doesn't look like this. It looks much more like this. In these worlds of very modular applications that are unaware of how they talk to the database, especially if they're using an ORM, the level of interactions between app server and database can skyrocket out of control. Just because an app server is co-located in a data center with the database doesn't mean that this doesn't come with a cost. And funnily enough, that kind of cost often leads to the people claiming, oh, the database is slow. When they look at their monitoring, it says a lot of our time is being lost interacting with the database. Therefore, the database is slow. We need to throw out our relational database. We'll move to Mongo or some other platform, etc. It's amazing how you can justify total changes in your system architecture just because you didn't understand the issues that come when you have chatty applications between the app server and the database. Let's talk about how evolving to PL SQL bit by bit might help in terms of solving that issue with database traffic. And let's focus on getting past that first fear of, well, is it going to cost me more to use PL SQL? After all, I'm going to be running more code on the database. Those databases aren't cheap. Is it going to actually cost me more? A common argument is it's another layer of code. If I'm talking ORM straight to the database running SQL, well, if now I'm talking some ORM talking to PL SQL, then talking to the database, that's more layers, it's going to be more latency. Is it actually going to make things worse? To explore this, we're going to start with the most basic of applications, a simple application that just does primary key lookups. Here is a snippet from my application, this one I've written in Java. You can see all we're doing is iterations of doing primary key lookups. It's the most basic application you could ever think of. It's obviously not a real-world example, but we're going to start very simple and build our way up to more complicated examples. So we're just going to iterate through doing primary key lookups. We're then going to compare it to its equivalent where we've introduced a PL SQL layer. The Java program now calls a PL SQL function which does the exact same query, that primary key lookup. We're going to iterate through that lots of times as well, and we're going to compare those two approaches. Java issuing SQL directly against the database versus Java calling PL SQL, which performs that SQL for us. Let's now jump into a demo and see how those go. So this program is called Simple PK, and as we can see here, we create a test table, and then I've done 20,000 primary key lookup iterations, and we can see the elapsed time was about 2.3 seconds, almost 2.4 seconds, 2,400 milliseconds. And I've also looked at how much database CPU we've used to actually achieve those primary key lookups coming from our Java application. We used 44 centiseconds, that's the unit of measurement coming from the database, of database CPU. Let's now compare that to the same program which calls a PL SQL module, which does that SQL for us. We run it again, it creates the same test table, does the same number of iterations. It was a little bit slower, and we used more database CPU. Here is the justification from those people that say PL SQL is just another layer, it's going to make things worse. And we get this, PL SQL is more expensive. There's the proof right there. There is an interesting irony here in that the same people are now saying, oh yes, because we had more layers, it became more expensive. Are the same people that used to write applications like this, where you had as minimal layers as possible, and nowadays their modern application stacks look more like this, where they've got Java calling something else, calling something else, calling something else, calling an ORM, going, microservices, REST, etc. We've got millions of layers nowadays in modern applications, and yet somehow saying using PL SQL is going to be a big drama. That's an interesting irony, but we'll come back to that. Let's now evolve that simple primary key lookup to something a little bit more real. I'm going to now take that application and make it into a simple API. It's very rare that an application consists of just primary key lookups. So let's make it a little bit more realistic. Here's my Java program again. This time I'm doing 3 different kinds of queries. A couple of lookups based on customer to find out some information, and also looping through the list of orders for a given customer, etc. It's a bit more realistic. I'm going to call this as an API and see how long it takes. Alternatively, I'm going to move those 3 sets of SQLs now into a single PL SQL unit. Once again, it's doing the exact same amount of SQL work on the database, 3 separate queries, one of them being an iteration query, but the Java program will simply call that function. So now we've added a touch more realism into our application. Let's give those 2 things a test and see how we go. Okay. So now we're running a Java program called Simple API. Once again, a whole stack of iterations. It'll be a bit slower because this time each iteration is doing 3 queries to the database. And we can see here it took almost 7 seconds, about 6,900 milliseconds, and we used 198 centiseconds of CPU. Let's now compare that to the exact same program using PL SQL as the API. Java doing 20,000 calls to the PL SQL routine. Now we're starting to get somewhere. Now we're starting to see perhaps the true value of using, say, PL SQL once you get into more realistic application scenarios. This is now over 2 times faster. It finished in 2.7 seconds as opposed to 7. And the key thing is it used a lot less database CPU. Now, that might seem a bit strange. I'm doing the same amount of work. I'm doing 3 queries. The key thing here is to remember there is a CPU cost to the database to actually respond to an incoming request. Because our original API in Java did 3 requests to the database for each iteration, each time the database had to sort of go, oh, you've asked me to do something, just responding takes CPU. Therefore, the less times you can call a database, the less database CPU you will use. So that second example in PL SQL, even though it's doing the same amount of SQL work, because it had to respond to requests less often, we use dramatically less database CPU. So 2 key points come out of that demo, even with this simple API now that we've got. Number 1 is it's not just about network latency. All of these demos are running all on the same box. The Java program and the database are co-located. So there was no network issue that's causing the problems here, just by the fact that we did less jumps to the database itself, even on the same box, actually gets you a performance benefit. It's not about the network here. And as I said, we use dramatically less database CPU. Why is this a key point? Because CPU is money. It's as simple as that. Whether you're using cloud, whether you're using any cloud vendor or running on-premise, almost all databases are licensed based on the number of CPUs you're using. Whether it's per unit of consumption on, say, cloud, or whether it's per core on premises, you're paying by database CPU usage. The less you use, the less money you spend. We'll come back to why that is the case soon, but we're going to continue on evolving our application into something more and more realistic. Probably the best way of making it as real as possible is rather than write something from scratch myself in Java, I'll take advantage of this facility. It's called Swingbench. Dominic Giles, someone who's been at Oracle for a long time, wrote this utility a long time ago to actually do various benchmarking of Java applications against the Oracle database. Because he's a smart person, it's a very well-written Java application, and it simulates real-world applications. We can do things like order entry, customer transactions, etc., all the normal things you would do in genuine applications, not like my trivial little API. One of the nice things of using Swingbench is the application has 2 modes. I can run it entirely with the SQLs coming from Java, or I can run the exact same application where those SQLs have been put into PL SQL routines and the Java application calls that. So as per our previous demos, we can do like-for-like comparisons of the benefit of PL SQL. So I've got 2 routines here. One's called SP Client, one's called SP Server, which simply are the same application, doing the same order entry benchmark, except one, the SQLs are coming from Java, and the other one, the SQLs are coming from PL SQL, called by the Java routines. Let's see a comparison between those 2. So we can see we're launching off a Java program here. And what this does is it actually outputs to us transactions per second. So it takes a little bit of time to ramp up, but we can see it's already at about 200 transactions per second. I'm not running any parallel threads here. This is simply single-threaded transaction performance coming out of a Java program, throwing SQLs directly against a locally running database. So it's almost reached its equilibrium point now. It seems to be settling at around about 300 transactions per second. Occasionally some peaks, but generally about that. Okay, so I'll give it a few more seconds, and then we'll enter it off, and it'll give us a little report at the end here. We can see we averaged about 250 transactions per second. That includes the ramp up time. Let's be generous. Let's assume it hit at about our peak here, which is about 300 transactions per second. That's very impressive on just a very old desktop machine here, but still, it's running Java, SQL against the database. Let's now compare it to the exact same application, but the Java calls call PL/SQL routines, which do the work on behalf of the Java routines. So SB server, exact same application, exact same workload, just sitting there single-threaded, smashing away as hard as it can. And already we can see we've jumped up well above the 300 transactions per second mark, and we'll let it keep on going. Where are we at? About 360, 378, 355, etc. Right, I'll let that run. You can see we're sort of pretty much reached the equilibrium point now. Once again, I'll kill that off. Well, we almost got to 400 there. So in this case, the average being 335. Using the same as before, if I look at, say, this last batch where we sort of reached our equilibrium point, this is probably what I see in most real-life applications. We went from 300 transactions per second to about 360. We normally get about 15 to 25% performance benefit just by moving our database calls into PL/SQL routines as opposed to calling them directly from our chatty applications. Doesn't matter whether it's Java, C#, Node, whatever. If you can encapsulate that database logic and put it into PL/SQL programs, you generally get a 15 to 25% performance jump. What that also means in reverse is it means you'll use for the same workload 15 to 25% less database CPU, and of course that means less money. And I want to give a shout out to Dom here in the sense that he's a smart Oracle guy. He really knows Oracle technology. So this is about the best you could do with a Java program. There's no inefficiencies here that he hasn't coded. He's taking advantage of all the benefits that we have inside JDBC talking to Oracle database, and he still can't meet the benefits you get from PL/SQL. This is the best a Java application can do. Even more so, it's running on the same box. So there's no network latency here. If we introduced a network layer, the differences would be even more profound. Hopefully that convinces you that performance is going to be better served by moving key application components into PL/SQL. Let's now talk about development. When it comes to how can development be helped by PL/SQL, there's obviously two elements here. One is the initial building of your application. Can PL/SQL help that? And the maintenance, the ongoing maintenance of application once it's live in production. Let's focus on the build first and talk about why PL/SQL can perhaps help you. The first benefit of having PL/SQL is the fact that it crashes early. Now that seems a strange benefit, but here's a quote from one of my favorite books, The Pragmatic Programmer. That is, a dead program does a lot less damage than a crippled one. And it's true. If a program won't even compile, it can't do damage to your production environment, obviously, because it'll never make it there. One of the problems with almost any 3GL language that can present SQL to a database is more often than not, those SQL statements are provided as strings, which means, as you can see there, I can literally throw any old piece of junk at a database and that Java program, that Node program, etc., will still compile just fine. It is blissfully unaware that that is invalid SQL. Compare that to PL/SQL. Because it's so tightly integrated with the Oracle database, the moment you put an invalid piece of SQL in there, the program won't even compile. As a programmer, you're getting much earlier feedback as to the correctness of your SQL statements. They never make it to a testing phase because you're told immediately at compilation time that the SQL statement is not valid. The second benefit of PL/SQL is the lazy way is the optimal way. Now, I don't want to accuse anyone of being lazy, so let's call it the efficient way. If you're writing a Java program or a Node program or C# program, the easiest way to run a query is to slam it into an execute command with your query string. Conversely, the proper way, the more correct way, is to use a prepared statement to bind the variables in, etc. It's more correct, and we'll see shortly it's very important that you do it, but it's more code. And generally, as developers, when we're under the pump for time constraints, etc., we often take the easy or lazy way out, so we use the first option. However, if you're not using the more lengthy code example here, you're in an awful lot of trouble. Because if you're building SQL by concatenation, you are going to get hacked 100%. The most common way people are hacked nowadays is via SQL injection. You've got a SQL statement that simply takes some argument from an end user, say via a browser. You're expecting them to type in something like, say, an employee number, but of course, someone malicious is going to type in something like this, as you can see in green. Enough of a segment of data such that it eliminates the top half of your query and now they're data mining your catalog to look for key tables, for example, with the word security in them. Should they stumble upon one, they'll then start running queries to look for things like usernames, passwords, etc. The moment you take input from the outside world and concatenate it into a SQL, you're running enormous risks of getting your site hacked. Conversely, pure SQL. Any argument that comes in from the outside world and that goes into static SQL is automatically bound. It automatically uses bind variables and prepared statements. There is no risk of getting SQL injection. Therefore, the easy way, the slackest way just to code the SQL is also the most secure way when it comes to pure SQL. In fact, if you want to build SQL by concatenation in pure SQL, it's hard work. You have to do a lot more coding, and generally people steer clear of this. This is an excellent incentive for people to write secure code by actually doing the lazy way. I will concede that in later versions of pure SQL, we introduced a lazy, easy way of writing dynamic SQL by concatenation. I'm quite sad about that. I wish we'd kept it hard, because the more we can steer people clear of that, the more secure their applications will be. People sometimes respond to me, they say, none of that's an issue for me because we don't code SQL directly. It all comes via an ORM, so that means we're safe. But don't forget, ORMs are just applications written by other developers, and therefore even ORMs can sometimes be subjected to security issues. In fact, there was a famous one with SQLize. So be careful. Just because you've abstracted away your SQL doesn't mean you're any more secure. The other benefit of SQL coming from inside your pure SQL programs is it's not just a debate about static versus dynamic SQL. Let's head back to the issue of performance, where we showed that the pure SQL performance was so much better, even though we didn't have a network chatty application here. It's all running on the same machine. When I run SQL coming from a pure SQL program, for example, here I'm looping through a set of rows with a piece of static SQL. If I was to turn a trace on that particular SQL, what I see is things like this. The first thing is, no matter how many times I execute that pure SQL routine, I only parsed the SQL statement once. Pure SQL has some enhancements to ensure that we parse static SQL as few times as possible, and parsing costs you in terms of CPU. Similarly, pure SQL has some enhancements such that it will automatically use array fetching. You can see there I actually executed the routine 10,000 times, but I actually managed to fetch 40,000 rows. We were using array fetching automatically just by using a for loop within pure SQL. A consequence of that is that the overall CPU costs, less parsing, less fetching, means the CPU cost was reduced. Therefore, we get better performance. Compare that to a very simple Java application which runs the same code, but just a SQL statement coming from Java. What do we see? We see we parsed it every single time. That adds to the CPU cost. By default, when we executed the data, every time we execute and want to fetch rows, we actually have to do a fetch every single time. So we had 40,000 fetches to get 40,000 rows. We weren't doing array fetching. The consequence of those two things, the extra parsing, the extra fetching, means an inflated CPU cost. Don't get me wrong, all those things can be mitigated against with Java, but once again, it requires more code. And as we know, when we're under time constraints or we're just being a little bit lazy, as developers, we often skimp on those things. So you can achieve the same performance with Java, but you have to write more code to do it. If you're thinking, well, hold on, you just demoed 300 transactions per second versus 360 transactions per second. I'll only ever need 100 transactions per second anyway. Maybe the performance is good enough for me without using pure SQL. That's fine, but then again, don't get wrapped up in what I call the hypocrisy of people saying, oh yes, I don't need pure SQL because my performance is fine, but by the same token, I need to have a 500 node Kubernetes cluster running microservices, etc., because that's the only way my application will scale. You really can't have that argument both ways. And perhaps the third benefit of having some modules of your application in pure SQL is that no application is ever what I would say 100% complete. You might finish your application, it's ready to go to production, and someone says, oh, yes, we need to do an initial data load. We need to do an initial population of data from some old system, the one that's replacing, etc. There's always these little extra things that come along that your application was never built to do. Having modules in pure SQL that take care of, say, certain APIs means they can be exploited in components outside your Java application. It might be for a data load, it might be for a data cleanse, it might be for doing some data maintenance activities once your application is live. All the utilities sitting there in PL SQL can be utilized by applications that aren't your core application. Otherwise, you have to write new code over and over again for those little one-off requirements that pop up. A common build criticism when we're talking about development cycles for PL SQL is people say, I don't have all those cool facilities I have in my other platform environments. If I'm using Java or C++, etc., I've got these IDEs that let me do private testing. I've got my own private sandbox. I can do everything on my own PC before merging to the main branch, for example. This is valid. This is a valid criticism of PL SQL that was valid perhaps in the past. But nowadays, the fact that you can get free autonomous databases literally at the click of a finger, so it's very easy to spool up entire cloud environments to have your own database, or the fact that we have multi-tenant now, which lets you have pluggable databases. It's very easy to clone environments. And in particularly, with pluggable database now from 19C onwards, you don't have to pay any money as long as you stay under 3 pluggables. So you can take a master development one, clone it 3 times and give it to developers. Similarly, you could take those pluggables and give it to them in 21C Express Edition, which has an unlimited number of pluggables for absolutely no cost. That's really, really cool because now every single developer can have a database on their own machine with unlimited number of pluggable databases to do private sandboxing of their applications. Once you've built your application, what about the ongoing maintenance of that application? The first benefit I have in PL SQL is the fact that you get free dependency analysis. One of the cool things that comes inside the Oracle database, not just with PL SQL, is this view called DBA dependencies, which tracks all the relationships between database objects. Thus, if I build a PL SQL routine that references the emp table, that's stored in the DBA dependencies view. It says that that procedure depended on standard, which is the PL SQL core package that sort of exposes the PL SQL language itself, and it depends on your emp table. So if I'm going to add a column to the emp table or drop a column, I simply have to look in this view and see what objects are going to be checked or need to be checked by me to make sure they're still going to work. I don't have to resort to grepping and searching through source code files to see what's going to happen here. The database tracks it for me. One common maintenance criticism that comes with PL SQL is that every time you want to deploy a new version of your code, it used to mean downtime. Now, this can still be true, but it's easily mitigated. The key thing is to use packages, because packages break the invalidation chain. If you deploy all your code in simple stored procedures, then if you change procedure D, which is called by C, which is called by B, which is called by A, etc., if you change D, then everything up the chain gets marked for recompilation. That can have a significant resource drain on your production system. However, if you put it into packages where you have the specification and the body and their separate components, then as you make code changes, for example, changing package body in D, that only impacts this package spec and therefore there's no invalidation chain there. Therefore, A, B, and C all remain valid, therefore you have no recompilation issues. Similarly, in the more recent releases of the Oracle database, you can even add components to this package specification. As long as they're added at the tail of the package, then once again, it won't cause any invalidation throughout all the calling routines. Therefore, as long as you use packages, you won't have any issues with deploying live deployments. Extending that even further is from 12C and beyond, we have edition-based redefinition. This is where you can have multiple versions of the same code active at the same time in your database environment. I can have version 1 of my code running at the moment. I can deploy version 2 in isolation, no one can see it, and I can slowly, for example, move people over to see it in terms of doing sanity checking or A/B testing, and then move the entire user population over to use my new version of the code. Just returning to my debate about utopia, one of the reasons people have often been fearful of edition-based redefinition is because they get told they have to embrace it in its entirety, which means database views, encapsulation, cross-edition triggers, etc., because they want to have 100% uptime all the time for application deployments. That doesn't have to be the case. A very happy compromise is, for example, just use EBR whenever you're rolling out changes to your PL SQL code. If you are changing dramatically the underlying architecture, the tables, the columns, etc., then take a downtime like you normally would. But if you're just doing Peel SQL changes to triggers, changes to Peel SQL packages, etc., EBR just for that is trivial to implement. You don't have to worry about cross-edition triggers, etc., and yet it can just be a great way of rolling out new code with no application downtime. Don't focus on everything being the utopian dream. Finally, let's talk about security. Benefit number one of using Peel SQL is the opportunity of better security. I don't want to sit here and create some picture that Peel SQL magically makes your environment more secure. It does obviously eliminate that risk of dynamic SQL in many places, but there's more to security than just that. This is one of the sort of heartbreaking moments when I get called to help customers, when you see their applications looking like this. They've got a Java application probably coming through a connection pool through JDBC thin clients, and they're all connecting as the schema that owns all the objects. So it looks pictorially a bit like this. All the connections are coming in as the schema that owns everything. That is enormously risky because a rogue piece of code has full schema privileges now. It can delete, insert, update, which is probably entitled to, but it can drop, it can truncate, it can alter, it can do all these things that might catastrophically destroy your application or your database schema. People often think there must be some sort of limit on schema, or maybe I think they do because they try to keep as few schemas as possible in their databases. There's no issue with having lots of schemas because no one should ever have a schema that an application connects to that owns any objects. In that way, you can always implement this policy of the least privilege being the best level of security privileges. Give people nothing until it's absolutely needed. Once you get to multiple schemas, you can have a policy of nothing ever connects to the owner of any particular database object. Pictorially, it looks a bit like this. All your precious objects are sitting here on the left in the schema that owns the tables, but everyone else connects to a different schema which has just the appropriate rights on that schema. Connections therefore have insert, update, delete, and select privileges on objects or tables in the schema owner, but they won't be able to do things like drop, alter, truncate, etc. Obviously, delete is still obviously a high-risk operation, but this way, at least we've got some degree now of protection of the objects in our database schema. Where Peel SQL is going to really give you some benefits is if you can move the database access into Peel SQL objects, now the only thing the connecting schema will have access to is the ability to execute Peel SQL programs. Therefore, all the controls about what can insert, what can update, what delete are now taken away from the connecting schema where your end users are connecting. It's all stored in your own code, namely inside those Peel SQL objects. This is where Peel SQL can help make your security much more robust. Once again, staying away from the utopian dream, you can have a nice compromise of that. Maybe anything that does changes to data, insert, update, delete, is stored in Peel SQL. But anything that does just queries, we'll just let your application schema just query it directly. It still has query access, but no alteration access. That is a nice happy compromise. Tools like Application Express do things like this. They query the database tables directly in database views, but you can control it such that all the update, insert, and delete stuff comes via APIs. Benefit number two is a corollary of moving things into Peel SQL objects when it comes to modifying data. If you have a system like this, where the only thing that will actually modify the data is Peel SQL code, then you don't need triggers. Because generally the only reason we put triggers on systems is to make sure that wherever the changes possibly come from, we're capturing them and doing some extra action. If the only place modifications can come from is in Peel SQL programs, I can put the trigger logic into those Peel SQL programs and do away with triggers. This is not to say that triggers in themselves are a bad thing, but the reality is triggers are hard. Triggers can be hard to code because you have to be so careful in terms of taking care of the locking and serialization and the concurrency model that comes with all that power of readers don't lock writers and writers don't lock readers inside the Oracle database. Let me put all that theory into practice now with a real-life customer example. I worked at a company before I joined Oracle, which had some relationship to gambling or horse racing in Western Australia. And the reality is, people gamble a lot in Australia. The application was a mix of C#, C++, all coming through a service bus, and Tuxedo was involved. It all gets funneled through WebLogic talking to the database. So it looked a bit like that. Now, to do something like as simple as I want to bet on a horse race, there's a lot of stuff that needs to go on before you're allowed to do that. We need to see the various things like, is the race open for betting? Is the bet type available? Am I allowed to place a win bet or a place bet? The horse has been scratched. If I pick horse number 7, is that horse actually running? What's my balance like? Do I have enough money to place the bet I'm putting on? Are there any restrictions on me? Am I a big high roller and they want to make sure I don't break the bank? Are there various restrictions based on legislation in terms of what you can do? Lots of checks that have to occur first before you can actually place your bet. Eventually you can place your bet, but all of that stuff means a trip to the database to do these checks. So whilst the diagram looked a bit like that, in reality, it looked more like this, a very network chatty application. And the problem was, under load testing for big race days like the Melbourne Cup here in Australia, which is so big a horse race that some places have a public holiday to bet on the race, we had these dramas. There were hundreds of really well-written routines in this application, all written in C#, C++. Did we throw them all away and rewrite the entire thing in PL/SQL? No. All we did was took out of all those hundreds of routines, we grabbed the 2 most common ones first. The ability for someone to place a bet, that's obviously critical. That's what a lot of transactions coming in. And the moment a horse race finishes is people want to get their ticket and say, did I win? It's like when you have a lottery ticket, you take it down and you want to see if it wins. We started with just those 2 elements. You put those 2 elements into PL/SQL because that would eliminate a great huge amount of the volume of transactions coming with chatty Java applications or C++ applications. Just put them into PL/SQL. That was fine. That's pretty much all we did. We started with those 2, and that got us over the benchmark requirements we had to handle things like Melbourne Cup. But the benefits can be really addictive. Once we had a few routines written in PL/SQL and our development team who hadn't really trained in PL/SQL started seeing the benefits of that, more and more stuff started morphing from C++ or C# into PL/SQL routines because they saw the performance benefits of doing so. Similarly, a few months back on one of our Ask Tom office hours sessions, we had a friend of mine from Israel, Oren. He said to us, we started moving a few things to PL/SQL in our applications, and as people start seeing the benefits, they want more and more stuff moved to PL/SQL. And yeah, once you get in that mindset of, I want to use PL/SQL, you'd be amazed how your developers can really embrace it. To finish off, let me address some of the common criticisms when it comes to PL/SQL. People say, well, it's not object-oriented, and let's face it, object-oriented languages are all the rage nowadays. But let's think about what the principles of object orientation generally are. OO languages have their basis in the fact that rather than expose attributes of objects, you wrap them and encapsulate them in methods. Therefore, the only access to attributes in your applications come through methods. Well, what's PL/SQL? PL/SQL is about wrapping code around your key data attributes, namely your tables, etc., and columns. The principles there are the same. Even though it's a procedural language, the principle is that of protecting data assets with encapsulation, and that's what the PL/SQL code is. Another common criticism is we don't have PL/SQL skills. I'd refer back to this customer example I just mentioned. They had no PL/SQL skills others, but let's face it, it's a very basic procedural language. It's got all the things like every language, if, then, else, loops, checks, etc. You don't have to be a wizard at PL/SQL. You just need to pick up the basics in order to move SQL statements into it, being able to pass parameters, return parameters, and pretty much you're 99% of the way there. Just that alone is going to give you some significant benefits to your applications. And I just want to finish off with saying, people say, oh, because I struggle with SQL, I'm therefore going to struggle with PL/SQL as well. Be aware that PL/SQL is quite different to SQL. The PL/SQL actually is the procedural language extension to SQL. So be aware, just because you struggle with, for example, very complicated SQL, doesn't mean you should dismiss PL/SQL out of hand. Or if you're a newbie at PL/SQL and you think, oh, I won't be able to write good PL/SQL. I've read Stephen Feuerstein's books and they all seem too complicated and there's so much to learn. It doesn't really matter. As I said, let's not focus on utopia. It's not about achieving these pipe dream perfect solutions. It's just about application success for your customers. With that, let me wrap up this session. It doesn't have to be a war. It doesn't have to be a religious debate or a philosophical debate. You don't have to move everything into PL/SQL. You don't have to use nothing in PL/SQL. You can easily have this happy compromise which makes your applications successful. Whenever you see people in the community talking about these 100% perfect solutions, remind them that application success does not have to be about utopia. PL SQL is very easy to learn, very easy to write. All you need is a text editor. Any IDE will handle it just fine. But that doesn't mean it's a dead language. Innovation continues in PL SQL inside Oracle organization. If you look at the new features guide, we can see we've done huge amounts of rework to the iteration processing now in PL SQL to provide a lot more power, a lot more flexibility and simplicity. Simpler code means faster to write code, easier to maintain code. And if you can give PL SQL a chance, I think you'll get some great wins for just a small amount of effort. That's the key thing. And that leads on to bigger wins as you find the benefits, as I said, can be addictive when you use PL SQL. If you want one last example of just a few baby steps helping you with PL SQL, here's my son Max. As you can see, a very keen PL SQL reader from a very, very young age. Yeah, nothing to do with the fact that I might have placed that book there very, very carefully. Hope you enjoyed this session. As I said, if you have any questions about PL SQL, you can always leave them as comments or reach out to me on Twitter, on my blog, or via the YouTube channel. Thank you very much for watching, and hopefully your PL SQL journey is just about to begin.
CloudDB, shaping your new normal.